Today I'm going to present you the topic of how actually not to write code. Usually there are like fancy presentation about how to write fancy code, and today I'm going to show you how to not write boring code. So let's get started. So my theory is that testing in iOS and Swift is not easy. The first reason is that is our fault, and because our code is hard to test. We wrote our code the way that, well, it's either impossible or very hard to test. And the second reason is that it's not our fault, but we can actually do something about it. But we need to do most of the things by hand. So in order to write good tests in iOS and Swift, we really need to write a lot of boring code. That I'll show you one simple trick how to avoid that. So let's get started with the hard to test code. Can you see it through this? I don't know.
Hardly.
Okay, hardly.
Can you read it loud?
Yeah, okay. I'll read it. But it's probably the code that all of you have written like several times, like multiple times in your development career. If not, so it means that you are just beginner. So that's how your life is going to look like. But that's a login service. So the service that logs user in. And it has, in our simplified example, it has two methods. One is a login, of course, that takes email and password. And the other one is logout, that, well, ideally logs out the user. And it works that way that login method takes email and password. It creates some kind of payload that is forwarded to our HTTP service. And then in some kind of callback, we get the response, we parse it, and we do something with the result. In our case, that's we expect a token, so we want to save it in our token storage. What I didn't show here, because this is like very simplified thing, is that it didn't show any parsing or calling in observers, callbacks, etc. So yeah, don't be hard on me here. And logout, well, is simpler. It just clears the token storage and maybe calls some observers, right? So yeah, like at the first sight, it kind of looks okay, right? So we have some service, HTTP, we have some storage, and we do stuff with it, right? But the spoiler is that it's not very good code. And let's start with the question: what actually we would like to test? In order to conclude that we cannot do it. So, for example, we would like to test if the email and password that we pass to our login service is correctly like structured and passed to the HTTP service, right? We would like to also to test how we handle HTTP service response. So, if there is a successful response, we would like to know if we correctly parse the result, right? If the token that we expect is correctly parsed. And in case of an error, we need to handle an error somehow. And like similarly to HTTP service, we would like to know that this very important token is correctly saved in our token storage. So This is the visible part of what we could test. In like real life scenario, we could also test if we have successful response, then we call correct observers for someone who's interested in response, etc. But this is a good start to think about how to test this kind of service. So what's wrong with the code, right? So we don't have an access in a way to the HTTP service, like how we could verify that something that we've created in login service was passed correctly to the HTTP service. Well, right? We can run the code. We can test if it's like if you get the response, etc. Right? But what I'm talking about here is about automated unit tests. So in this case, like just testing it once, it won't work the way we want to work. Which means that we want to have tests that we can like run all the time, not do it manually, right? little bit more bigger red flag is that it seems that calling a send method on this HTTP service, right? Well, it's here. It seems that it will fire the actual HTTP request to a server, right? So this is wrong for two reasons. Why is like we actually send some request, like it could be a debug server, which is not good, but it's not the end of the world. But if we run our tests on the production server, that's something we shouldn't do. And the other thing is that when we send this request, we need to wait for the response, right? And waiting for response, well, the first thing is asynchronous. And so it means that we need to wait for the response. And waiting for the response from the network is in terms of like, compared to the times that we would actually want to have in our unit test, is very, very long. It's like infinity. So we don't want to wait for it. And we don't want to also be dependent on some kind of some external dependency, external service. The server might not work. We might not have the internet connection on our laptop or on our CI. So this is something that we want to avoid because we want to have like reproducible tests. And in very similar fashion to the HTTP service, we don't have access in this way to verify things in our token storage. Well, the name actually suggested this is a file system token storage. So in theory, we could like check in the file is there actually like saved somehow. But still, this is again something that we don't want to test. We want to just test it if this token storage will receive the token that we expect it to receive. So this is again kind of like talking with some external dependencies that we don't want to do. So unit tests for us. There are long and wise definitions what the unit test is, but what I wanted to focus here is that we want to have isolated tests and we want to have tests that are fast. And these both cases are not like fulfilled in our code. So tests are not isolated and tests are slow. But fortunately, there's a way to get out of this mess, and we can use two things that will make 95% of our untestable code testable. So we will use protocols, and we will use something that's sounds pretty scary, but it's very simple. What this technique called dependency injection. So protocols, yeah, everyone who writes in Swift knows what it is, but for those who are not writing in Swift, this is just the interface. So this is the Java interface of Kotlin one. So what we need to do, we just need to follow these steps, basically, in most of the cases. For every class that we use in our object that we want to test, we need to make it a protocol. Because if a class is not a protocol, it's impossible or like hard and unreliable to mock it. And if we can't mock it, we can't unit test it. And by mock it, that's me like, I don't know. I think the correct term is test doubles, but to simplify things and definitions here, like mock it, I will show you a mock, and this might not be a mock, but so yeah, these protocols and dependency injection. Recently, I found this tweet when I was refreshing this presentation. I love to use dependency injection, which means I love to pass values to functions. So this is it. But to wrap within more like object-oriented terms. So instead of creating objects which are dependencies inside a class, we create them outside of the class in something that's called dependency container. That I want to talk about because Błażej from Toptal was here when he was talking about dependency container. So if anyone's interested, you can go back to the recording, which I think exists, right? So so we create them objects dependencies outside and pass through constructor or property. So it means inject. So yeah, let's do it. So let's combine these two things and see what's the result. So let's identify. Okay, so probably it's not very visible. So let's identify dependencies that we have in our login service. So the first dependency is our HTTP service, and that will create object that's from is URL session HTTP service class. So that's the first dependency, and the other one is token storage, which is which has a type class type file system token storage. So yeah, so let's define protocols for these two. It's probably not visible, but what we need to do, we need to just look at which methods of these from these classes we are using in our object that we want to test, and just extract those to a protocol. So in terms of our network connection, we just use send method. So let's create a protocol HTTP service with method send. Yeah, that's here. And in terms of in case of protocol, in our protocol for token storage, we use two methods. One is a save that takes token, and one is a clear that takes nothing. It's just a void method. So yeah, so now when we have these two protocols, we need to use them instead of concrete classes. So now our HTTP service will have type HTTP service instead of this concrete NS URL session HTTP service, and token storage will be surprise surprise token storage instead of this concrete file system token storage. And now we need to since these are private properties, we need to create some kind of entry point for being able to inject those two, right? So we add the constructor which takes HTTP service and token storage with these protocol types, not the concrete ones, and assign them to properties that we've defined. And this is all we need to change in our code here in this class to make it testable. So no other logic, no other call, anything has changed below. One thing that has changed was that we've added the constructor. So this is good, but this breaks backward compatibility with objects that are already using our login service. So in order to avoid that, if we don't have dependency container, we can use Swift's default arguments values. So we can say that HTTP service default value is URL session HTTP service that we've used before. And similar to token storage, we use file system token storage. Why are we doing this? Because we can tackle this problem from two places. One is that we're writing code from scratch. In defining new classes, we don't have a problem with backward compatibility because we're not using them anywhere yet, right? So we define protocol, we define interface in it, we define concrete class, and then inject it somehow. But if we have a code that is not testable and it's already used in several places, we need to, ideally we would like to not change anything at all outside of this object that we want to test. So this is like the simple trick how to maintain backward compatibility and have testable code. So that's it. That's all what we need to do. So now we can replace the implementation of dependent objects, which means we can, without changing a class that are using it, which means we can now create mocks and inject those in a class, in this object. And like I mentioned, we can do that anytime. So this is a technique that either can be used in brand new code that we want to test, as well as the one that is the code that we are maintaining and want to at some point test it. I know that probably lots of you either had this experience in the past or currently have it, that you work in the place that, or like in the project that, maybe not doesn't allow unit testing per se, but it's usually often it's like said that there's no time for it, right? So yeah, that's I know the feeling, but you can prepare your code like beforehand, that for testing in the future. So if you use these two things, you always define your dependencies outside of the object and use the dependency injection. I would say that 95% of your code will be ready for unit testing, and then if you decide that you want to be sure that something works correctly, and it's a very special case, then you can do it. So yeah, that was the first part. So we have a bad code that's not testable, and we want to change it, right? We want to make it testable and write tests. And now that's like the preface for the second part of not writing code. I just wanted to like things that I will show you later are like kind of this is teamwork that we did, because I work at Toptal, and this is stuff that we use and did in our project to test it so nicely. So the team at the time of creating this presentation was Ciprian Bela, which is our QA guy that writes UI tests. It's Błażej Biesiada. He's from Krakow and he did have a presentation here. And also Paweł that's standing back there. And myself. So order is alphabetically, but I think I did the list of all of these things that I will show you. But yeah, anyway, so our like testing stack or like technologies that we are using, and we are happy with it. So it's like Earl Grey is a library for UI testing. So if you want to write a UI test, we recommend Earl Grey. Previously, this is I think library from Google, and we write tests in Swift. With previous app we use Appium, which was not very good. So we also use Snapshot, which is as a part of our unit tests. This is, I think, a very cool thing if you don't have any tests at all and you want to start adding those to your project, and it creates the snapshot, the screenshot of your view, and then when you run unit tests, it compares the view with the base screenshot that you've created. So you can identify any layout errors very quickly. We use Quick and Nimble, which is correspondingly BDD framework and like Butcher assertion framework. Just check those out. And we use Mimus and Sourcery that I will tell you more in a second. So yeah, so doing things by hand. This is something that we actually can blame on Swift. We don't have like this dynamism or like dynamic feature or affections that we used to have in Objective-C or in like other model languages. So we start by doing things by hand. So let's go back to our login service. That now we actually need to test interaction with our login service. So we need to define protocol that has the same interface like we used before. So it has login with email and password and logout. So initially, when you start writing tests in Swift, probably you do something like this. You create everything by hand, which is define mock login service that implements login service. And what we really want to test in this case is that we want to check if we passed correct values to login service. We don't care at this point if it's sent somewhere or not. We just want to know that our logic is correct and passes correct values to login service. So we need to somehow know which values we've passed. So we need to have defined like captured email and captured passwords properties here at the top. And we also might want to know how many times this method was called. So we need to have counters. One for login called and one for logout called. So yeah, this is how we used to do it. How Swift forces us to do it. So and using it might look something like this. So we create a mock, we inject it somewhere. We test the code, and now we need to check, right, if the login was called just once, right? Because maybe in the past it was called twice, I don't know, we want to be sure right now. Then we need to check if the email was passed and if the email is actually correct. So we need to check, well, if the captured email property is not nil, and then we need to check if captured email is actually the one that we expect it to be. Similarly is for captured password, and for logout, we just check if it was not called. Maybe in the past we had a code that called login and logout one after the other, so we just want to be sure. And yeah, we actually need to check, or like we really want to check if we actually captured an email, it's not nil, because later we use like force unwrap, so we don't want to crash our tests. Because we want to run like every test and see all of the failed results and not stop in this place. Yeah, we could use like if let, some guard, but basically it would like be the same or like even more lines of code. So yeah, so this is example, like actually very simple. Usually we might have much bigger classes that we need to implement much more of these captured values. If you have a callback, we would need to also capture that, etc., etc., and we would need to assert these values this way. So this is not exaggerated. Is well, we could say this is a real life scenario. So yeah, but Mimus to the rescue. Mimus is a library that is created by Paweł back there, and when he joined Toptal, he forced us to use it. No, he was just suggesting that, but that was a good choice. So this time things looked a little bit different, and so our mock need to implement this mock protocol from the Mimus, and we need to define a storage that where we will store recorded calls. So now our login method in our mock will look like this. That from Mimus we will call record call with identifier and with arguments that we've passed there. And for logout we will do the same without arguments. So this is how our mock implementation looked like. So it's already much better. And this is how assertion verification, if it's worked correctly, looks like. So we create the mock as usual, do some testing, and now Mimus gives us this verify call method with identifier and arguments. So yeah, we verify if this method with this identifier was called with arguments in this particular order. And for logout, we also have this mode that this was never called. Yeah, so as you can see, this looks much better. Thanks, Paweł. But it's not perfect. Sorry, Paweł. So yeah, so two things, right? The one is that we have this identifier that is a string. So we either need to create some enum or struct or a constant that we will share between recorded call and verify call, in order to not make a stupid typo mistake. And we also have arguments in an array that, first we need to know what was the order of code of the method that we want to verify. So we don't know the order, and we don't know we need to remember the order, and we need to remember how many arguments are there. So these things could be improved. What would be nicer use case of this testing scenario? How about having this kind of code without writing any code? So now our mock have this verify method on which we can verify if login was called with email and password. And similarly, we can check that logout was never called. So in this case, we know what is the method. So we know every login service methods, and it's auto completed by the Xcode. And we also know every argument and the order and how they look like, what we should test here. So yeah, that's kind of awesome, right? Yeah. So in order to achieve that, we will also need to use other tool, Sourcery, that was created by Krzysiek Zabłocki. Probably he's not here, but he's from Warsaw, so you know him. And Sourcery is meta-programming for Swift, which meta-programming means that we write programs that write programs. And usually it's used in auto-generating code that we don't want to write at the first place. And we don't want to maintain it. A little bit outdated example how Sourcery works, but it shows the main principle and the main use case of what it saves you from what is. It's implementing a quotable protocol for structs, for example. So if you have person with 3 properties, and one thing we need to do is to say that it's auto-equatable, and this is the protocol that's from the Sourcery, and Sourcery will check our code, look for these auto-equatable protocols, and will generate this code. So we'll take every property and write this this code that we never want to write, and that is error prone. So so it would make our person equatable. Swift 4 already has that, but this is just gives you a sense what we can achieve. So yeah, so let's combine these two libraries and tools, and in order to get this, like what I showed you, we just need to write this. We can just say that LoginService implements Mockable, and Sourcery will find this protocol and will generate this code. You can't read it. That's on purpose, because this is what actually Sourcery generates for us. So it shows the amount of code that you don't need to write, and amount of code that you would need to write if you would want to have this kind of nice API that I showed you before. So yeah, this is exactly what Sourcery generate. It's not something like this copy paste from somewhere. This is for this protocol with two methods, right? So yeah, this is quite a lot. We don't want to do it by hand. So yeah, so how we achieve that? We took the already existing there is already existing Mockable protocol. I'm not sure if that's in Sourcery or some separate gist. Yeah, but we took that and expanded it to use it to make it more suitable for us. So a little bit more advanced. And the result is that at the time making this presentation was like a month ago. We had like 193 automatically generated mocks, and it was almost 10,000 lines of codes that we didn't have to write and we don't need to maintain. So yeah, I call it a win. So yeah, that's it. In summary, in order not to write 10,000 lines of code, you need to write some code. So prepare your code for that. It's not entirely for free. So define your dependencies as protocols, use dependency injection, and then your code will be testable. So then you can fully use tools, and you can modify them for your needs. And I'm sure that it will benefit not only you, but the whole team you're working with, because they can use it as well. So thanks. That's all. So any questions?
So you are using the Mockable, which is a protocol, right?
Yes.
And you added to other protocols.
Excuse me?
You added to other protocols, right? Did I understand it right? You add Mockable to other classes,
yes.
Right?
So yeah,
The question is, does it land in the production code? Is it cut out?
Yes, it is a production code, but Mockable is just in Sourcery you can do like it in two ways. You can define a protocol that is empty, so it's just something that tells Sourcery that this needs to be generated. You can also use like comment with some defined annotation. Like you don't have annotations in Swift, so you just define comments. So, but we've decided to use protocols. And generated code, the Mockable mocks that we generate are like just used in tests. So
okay.
Yeah.
That's the question actually.
No. Yeah.
The other. So these tests are like quite a degree of white box testing, right? Can you actually do like true black box testing with Sourcery and Mimus?
Like
to some degree assume that tests have some knowledge about the test classes. Can you actually completely do a black box testing with this solution that you presented? Like you care about the outcome only. You passed something, you don't care whether this was actually passed, because that's what I understood. You passed these and you assume that this was passed correctly, but with black box you would assume that you passed something and the resolution is correct, right? Can you actually do this?
Well, I guess you can. It's it's if you want to, but still you talk about like unit testing or like more like yeah. Yeah, it depends. I think what you need to like test, right? You can define your own like mockable like this stencil, so you can expand it in different ways.
Okay. Do you use stencil for templates?
Yes.
And how did you figure out, because I didn't saw it, did you figure out how how can generate methods which return some types or generic methods?
Oh yeah, yeah, generics. We don't auto mock them. So yeah, this is because Sourcery is based on Source Kitten. And they do not have very good support for generic stars. So yeah, yeah. So we do it by hand, but it's a very small percentage of our code.
And then about specify a return type for your mock, because if you've got a method which returns some, I don't know, int strings or something.
Oh yeah, yeah. So we define this kind of default value for this simple types, for example, string and date, etc. So this is done via the extension, and if you don't provide it, it will just not compile. So yeah, you need to do it.
Do you use some link to dependency injection or just property and constructor injection?
Well, yeah, we don't use any library for dependency injection. We have this dependency container that we did by hand. But I think next time I would vote for using some kind of library. Yeah, but we do it by hand.
If you would use a library, which one?
That was quite some time. Long time ago when I checked those, but there was a Swinject, something like that. Yeah, I think it looked nice, but we thought that is just dependency. We can do it. Well, yeah, probably I will need to research again.
Yeah, about the Swinject, I was afraid using it because it's done on runtime, some part of injection, so some things you can. Yeah, miss. So I think there was some library, but in some alpha state or beta, that was generating some code. Or I'm not sure, but it mostly did the injection or in the build time. So but it was early stage. So.
Okay, yeah, yeah. So that's also like some part of it is on Swift, right? But you can just easily start with doing your own very simple dependency container, but you need to watch out in the process how much it grows. So maybe it's better to. It's hard to tell, right? It's not terrible, but it could be better.
Yeah, it depends on the size of the application.
Yeah.
Also.
And how also I think you should consider, but it's hard to consider like beforehand. But life cycle of the objects. That's for example, this like True. So yeah.
Thanks.
Yeah. Any more questions? Okay. So if you have more questions, I'll be here around. I think so. It's gonna be in Polish as well. So yeah. So thanks.